Good morning, anatomy students. This will be the final lecture for chapter 15, the fourth lecture. This is a long chapter, as you can tell. The last few chapters, even though we've been doing them online, I've covered in 2 or 3 lectures. It probably requires actually one more lecture, but I'm going to put 2 major topics together. So the last time we talked, I discussed the functionality of the small intestine, how it completes digestion, and or things that come from the small intestine complete digestion, enzymes from the pancreas, bile from the gallbladder helps with absorption, and then we move those materials, those nutrients, into the bloodstream through transport processes and into capillaries, and then we take them around the body so the cells can get the nutrients that they require. Obviously, that's the reason that we eat, to get those nutrients to our cells. Now, what's left over? What's left over is a lot of water, some dissolved salts, some solutes, and indigestible food. That's going to continue its pathway through the small intestine, and in the lower right quadrant, right down here, is where the small intestine joins the large intestine. At that point, the large intestine travels up. That's the ascending colon, and then it goes across, it's transverse colon, and then it goes down, that is the descending colon. So it makes pretty much 2 big bends, 2 90-degree turns, and then it terminates in the anus, which is the exit point for the indigestible food, or the feces, at that point. Now, before it gets to that point, there are still some things that the body is going to take from it. There are going to be a number of things that are very important. So the large intestine isn't just for processing fecal matter. That is one of its functions, processing and storage of fecal matter, indigestible food. It also reabsorbs a lot of water. In fact, the majority of the water balance that your body needs to maintain occurs between the kidneys and the large intestine, taking that excess water out of the indigestible food and bringing it back into the body. So there's absorption of water. There's some nutrients that are dissolved in those fluids as well, some vitamins, minerals, other things that are dissolved, other solutes. Don't want to understate, I would spend more time talking about this in class, but we have a symbiotic relationship with a bacterium called E. coli, which you've probably heard about, usually in a negative context. E. coli, if it gets out of our large intestine and gets into other parts of our body, can cause serious and sometimes life-threatening infections. But E. coli, as long as it remains in the large intestine, does a very important job for us, and I said it's a symbiotic relationship. We give them food and a place to live, room and board, and they break down some of those foods that we cannot break down to make them easier for us to pass out of the body, and they also release some vitamins in doing so. And that's obviously our benefit from them. So we have evolved, as many other organisms have as well, to have these bacteria that inhabit our guts, inhabit our large intestines. They're very important for health. When we disrupt them, we could tell, like when you take antibiotics, sometimes the antibiotics could destroy your population of E. coli that are in the large intestine and cause some major issues. Typically, you'll see that as gastrointestinal duress, like maybe gas, bloating, a little bit of diarrhea, but those have to reestablish themselves. You have to have a certain level of bacteria living in your gut, in your large intestine. So again, kind of summarize, large intestine processes indigestible food, reabsorbs water, place for E. coli to live, so they can do the things that they need to do with what is left of the food. And again, technically, we don't add anything to the large intestine. There's no other foods coming out of there. Everything that's left in the large intestine are food that just did not pass into our body through the capillaries. So that's the body, how the body deals with that indigestible food that we take in as part of our diet. So once that process is completed, there are a couple other organs, obviously, that we should talk about. These are called accessory organs of digestion. The pancreas, which I've already mentioned, which sits underneath the stomach. We talked about it back in chapter 10, having endocrine function, releasing insulin and glucagon, which help process those sugars that you've digested and absorbed. But the main function digestively of the pancreas is to release enzymes that help complete digestion in the small intestine. It also releases sodium bicarbonate. Sodium bicarbonate, which if maybe you've heard it from chemistry class or physical science, is baking soda. But we don't have a little Arm & Hammer container in our pancreas. It's obviously liquefied, it's dissolved in fluid, and what it does, it's a fairly strong base. It neutralizes the stomach acid that is going to be entering the small intestine from the stomach. So it helps to neutralize that, because the small intestine, just like the esophagus, as we mentioned, is not equipped to handle the acidity that is inherent or are part of the stomach's chemistry. So that sodium bicarbonate is going to help neutralize that acid and make the digested or almost digested food easier for the small intestine to handle. The gallbladder, as I mentioned, stores bile, which is produced in the liver. Bile is an emulsifier. It attaches water molecules to fat molecules. It makes it easier for them to pass through the walls of the small intestine for absorption. So that completes digestion. Now, the last section of the chapter, where we typically get into homeostasis, effects of aging, which we are not going to be doing in this chapter, is a whole section on nutrition. I just want to define a few terms. Nutrition, or nutrients, are things that are needed by the body to maintain physiology, to maintain homeostasis. These are things that your body needs to function properly. Nutrients come in many classes. If you want to see a list of nutrients, grab a cereal box or even a bag of potato chips. They'll have them all listed on the back. What percentages, your daily allowances and whatnot, are in that food item that you're looking at. So nutrients are things that we need to survive, to maintain physiology, homeostasis. Now, sometimes nutrients are broken into two categories: vitamins and minerals. They're usually used in the same sentence, and people don't usually try to discern their meanings, but they are different. All right, a vitamin is typically an organic molecule, which means it has the element carbon as part of its chemical structure. It's not typically, it is. Vitamins, how do they work in the body? They usually form or work as catalysts, which means that they help chemical reactions proceed quicker. They typically are not consumed by the reaction, and they don't become part of the body per se. Good example of a vitamin is vitamin D. We all know what vitamin D is. When you think of vitamin D, you think of bones. Your bones don't have vitamin D in them, right? Vitamin D allows calcium to be absorbed by the matrix of the bone tissue. So vitamin D is a helper, it's a catalyst. Minerals are inorganic. They do not contain the element carbon. Things like calcium, things like zinc and iron, very important for our body's physiology and functioning. They typically do become part of the physical structure, like calcium becomes part of the bones. Iron will become part of the heme group, which is the hemoglobin molecule protein that helps to carry oxygen in red blood cells. So what I'm going to do on this next set of questions, which will be the final set of questions for this chapter, before we have the assessment middle later of the week, this week, is I'm probably going to ask you to take a look at these lists in your notes. So make sure that you look at the notes. I know they're on Google Classroom. I'm going to ask you some questions about vitamins and minerals that I didn't just cover now. So this will be the last lecture. We'll complete this chapter sometime midweek, and then we'll move on to chapter 16. Have a good day.